So I printed off some rules that I'll be going over today and then I'm gonna hand around a stapler. If you wanna, so that would be like another cheat sheet, and if you wanted to staple it to the back of the last cheat sheet, you could. If you wanna just keep it separate, that's fine too. And then if you guys wanna staple that, or if you just wanna keep it separate, either way, but I'll hand that stapler around. So if you wanna staple it to another cheat sheet, you can. Right, so we are going to go over a couple of different things today. All of the logs that. Did everybody else get a note sheet and a formula sheet? Just have to have it like that, so. Okay, so today, what we're gonna do at first, everything that we have done up until this time has been what is just called a regular common logarithm, okay? And so sometimes we said log base 6 of 10, something like that, okay? Do you guys remember if they don't say a base, if they said like log of 6, do you guys remember what I said that you assume this is 10? Okay, so if they don't specify, it's log base 10. And the log key on your calculator is base 10. Okay, so sometimes they specify, in fact, most of the time in the problems they do, but if they don't, you assume it is 10. What we're gonna learn today is a number in math. It is named, it's E, and it's named after the mathematician Euler, or actually it sounds like Euler. But it's like pi, it's like the square root of 2 in that it keeps going forever. And basically, if somebody had to approximate what E was and ever put in a value for it, 2.718 is about what you would do. But E is a number that we use with logs. And the reason is there is something that is called a natural log that we're going to use today. It looks like this. So ln, it's a natural log. And when you see something like this, a natural log is log base E. And so one of the things we'll be doing today is switching from natural log to exponential form and back. Okay, so that will be one of the things. Now, when you notice here, this is the graph of e to the x power, e being Euler's number. And this is the graph of natural log of x, and they're inverses of one another. And what that means is, like, if I draw the line y equals x, we did this a little bit this year, and you folded the graph in half, e to the x and natural log of x would match onto one another. They're inverses of one another. So the reason we study E when we talk about logs is that the natural log that we're talking about today is log base E. And again, you don't really even have to know what E is, but it is 2.7182818, and it keeps going. Okay. So now this part's pretty easy. There is a natural log key on your calculator, and it is to the left of the 4. Okay. So if I gave you any problem today and I said, find the natural log of whatever, like in this problem here, it says, find the natural log of 125 to the nearest 10,000. All you have to do is hit this natural log key, 125, enter, and we're going to again round to the nearest 10,000, which is 4 places. So 4.8283. So 4.8283. Again, if we do this next one, we would just go natural log of 0.835, and you can get negative again. So negative 0.1803, negative 0.1803. Okay. Natural log of 95 minus natural log of 181. I do have to show you one thing when you do this. When you do natural log of 95, you either can hit enter and then subtract natural log of 181, or you can just put a parenthesis there and then go minus natural log 181. And here you don't really have to put a parenthesis. You could, but you don't have to. That is the same as going natural log 95, enter, subtract natural log 181. So whatever way you like better for that. And this one's going to be negative 0.6446. This next one, same thing. We would do natural log 65 and either hit enter or do a parenthesis plus natural log 100. And I get 8.79 or 779, and this would round to 6. So 8.7796. And then this last one where we're just punching in, we're going to multiply 2 logs. So we're going to go natural log of 931. And then again, you could go enter or do your parenthesis, and then it's multiplied. So I'm going to go times natural log of 32. And I get 23.6927. so those should be pretty easy points. You're really just punching that into your calculator. All right, so our next two things that we're going to do here is we're gonna convert, kind of using that log loop, we're gonna convert from exponential notation to logarithmic form. So it kind of shows the progression here, what to do. So if I have e to the x equals 12, the first thing I do is write it in log form, like log form, not natural log form. And I do log, and you kind of put things in the order that you would get when you do your loop. So the e goes here, that comes first, the 12 goes here, and it equals the power, okay? Once you get that done, log base e is the same thing as natural log, so you can just replace log base e with natural log. So I'll show you how I would do this. So again, log, if you think of that log loop, the e comes first, that's your base. The 8 comes next, that goes here. The power always goes here. Once you get that, all you have to do is rewrite it and replace log base e with natural log. And that would be your answer. Okay. So if I look at this next one again, first thing I do is I go log. If I think of this as my log loop, e comes first here, then the x would be here, not as a subscript, it would be right up here. And then it's always equal to your power, which is the 5. Once you write it like that, all you have to do is replace the log base e with natural log. Same thing with this one. Doesn't matter what this is, what the power is, whether it has a plus sign, you do it all the same. So you'd go log base e. Again, what comes next is my 45, and that equals 3x. Okay, and then what I would do is replace the log base e with 45, and that equals 3x. Is that easy enough? Okay. Bless you. Now, if we go down here, we're gonna just do the opposite of that. So on the ones up above, they gave us exponential and we put it in natural log form. In this one, they're giving us natural log form and we're putting it in exponential form. So it kind of shows the progression here again. The first thing you're gonna do is replace that natural log with log base e. That's all they did from here to here. And then you do your log loop where e to this power equals 4. Okay, that's what the log loop is. So if I go to do this, the first thing I do is go log base e, and then I write it just how it was, 10 equals x. So all I did there is replace natural log with log base e. Then I do that little log loop. So it would be e to the x power equals 10. Okay. And then that would be my answer here. Okay. So this one, all I do is switch natural log to log base e. And then when I do that, this just stays x, this stays 8. All I'm changing is natural log to log base e. And then if I do that little log loop, it would be e to the 8th power equals x. And then this one here, I would rewrite natural log with log base e of 4x. equals 9.6. Okay. And then what I would do is go e to the 9.6 equals 4x. So it's e to the 9.6 power equals 4x, and that's our answer. Now, this is just taking the last two examples and kind of mixing them together. So that's all this is. Sometimes they start in exponential and you want to put it in natural log form. Sometimes they start as natural log and you want to put it in exponential form. Okay, so it's just like the previous two examples. So if I went to do this one, remember what we do is we do kind of that log loop and we write it as log. The e comes first, so that goes here. The 3 comes next, so that goes here. And then the power comes last, so that goes here. Okay. Then the only thing I have to do at that point is replace log e with natural log. So that is my answer. Now, this is the other kind, and what you do on this one is you first replace natural log with log base e of 18 equals x. Okay. And then we need to take that and change it to exponential form. So if we do that log loop, it would be e, okay, to the x power equals 18. So e to the x power equals 18. So this next one is in natural log form. So I'm first going to put it as log base e and keep everything else the same. And then I have to put it in exponential form. So it would be e to the 42nd power equals x. Now, when I do this one, it's in exponential form. So the first thing I do is write it as a log. And again, if you're thinking of this as that log loop, the e goes here. The next thing to come is the 8, so that goes here. And it equals that power, which is here. And then the only thing I have to do is replace log of e with natural log of 8. If I go down to this one, again, this one starts in natural log. So the first thing I do is just change natural log to log of e, keep everything else the same. And then I do that log loop to put it in exponential notation. So I'm going to put it as e to the 36th power equals x plus 4. And then this last one here, again, is in exponential form. So the first thing I do is just put it as a log form and then to a natural log. So it would be log, and if I think of this loop, the e would go here. The next thing that comes is the 2, and it equals the power, which is x minus 3. And then I started in exponential form, changed it to log base e. And then the last thing I do is just replace log base e with natural log. And then it's 2 equals x minus 3. Is that okay? You guys get that? So now we're gonna do one more thing with logs, and some of these powers or some of these log rules we've learned before. So we're gonna go over them, and then I have a slide that has the sheet that I just handed out to you guys, and it has them on there. So we talked about this log rule already, that if you're taking the log, and it can also be the natural log. So all of these work if you had natural log, it's the same thing. So it wouldn't matter which one you have, if it's log or natural log, all the properties work. So when I'm doing log base b of m times n, remember to expand that. When it's multiplying, we add. And then today we're going the other way where they'll have it added and we want to condense them down. So what happens if they're added, to switch it, you put it as multiply. Okay. Then if I go down to this one, we've also talked about the quotient rule. And that is if you have the log or natural log of m divided by n, that is the same thing as the log of m minus the log of n. Okay. If they're divided and you want to expand them, you write them as separate logs with a subtraction. If they're subtracted and you want to put them together, it's called condense. To get rid of subtraction, you divide. And then we've also talked about the power rule a lot. If you ever have a power, you can move that power out front. And then also today, sometimes you'll have the power and you want to put it back. And so what would happen then is sometimes you move that power back up. And it depends. Today, we're going to do something called condensing logs. Tomorrow, we're going to do expanding logs. So today, we would have this and we would expand it or condense it to this. Tomorrow, we'd have this and we expand it to this. Okay, and you'll see that as we go through. Now, one rule that I haven't talked about at all is the log of 1. No matter if it's natural log, no matter what base it is, the log of 1 is 0. Okay, that's what the 0 rule is. This is anytime your base and this number are the same, your log is 1. And what I mean by that is, say they said log of 6 and this was 6 and they wanted to find that. If these two numbers are the same, your answer is 1. That's what that rule means. This rule is anytime, again, these two numbers are the same, but this is to a power, okay? These two numbers are the same, but this is to a power. What happens is this kind of goes away and your answer is just that power. So if you had log of 4 to the 4 to the 3rd power, your answer would just be that power. If these two are the same, then what happens is you can kind of ignore this and 3 would be your answer. Then this last one looks kind of confusing, but if you have a base to the power of log with that same base, this cancels and your answer is just K. So what that would look like is, say that you had 6 log base 6 of 100. Okay, this you can kind of just think of going away and your answer would be 100. It could look like 12 log base 12 of 16. This, if these two are the same, your answer is 16. Okay. Now today, the ones that we're going to use is these first three, the ones that you're familiar with. And this just shows you the product property, the quotient property, the power property. They work if it's log, base, whatever, or natural log. They work the same way. So sometimes in the problems today, I'll have three different things. Sometimes I use just natural log. Sometimes I write just log, and then you're assuming it's 10. And sometimes I do log base 6 or something like that. Regardless what these are, I can use any of those properties. Okay. So now we're going to learn how to do what's called condensing logs. Okay. What do you guys think? Should we? Yeah, I think I can get through this. Okay. So basically what happens, as we've been saying, is if they have just one log and two things are multiplied, you can expand them and have the two individual logs added together. That's what we're going to do tomorrow. Today, what we're going to do is the two individual logs are added and we're going to condense them down. And when they're added, to condense them, you write them as a single log with these two multiplied. Okay. So here is what your problems are going to look like today. So you sometimes will have a power. If you have a power, you're always going to take that power and move it up to the power, or whatever's in front, you're going to put it as the power. So when I do this one, I'm going to think of this as log base 5 of x to the second power. Okay. The second one, I'm also going to move that 12 to the power. So it's going to be log base 5 of y to the 12. Okay. So all I did is took these numbers and put them as powers. But I'm not done today until I have one single log. And right now they're added. Okay, so if you look at your little sheet here, if they're added and you want to write them as a single log, you have to multiply those two together. So if we do that, what I would write as a single log is just x squared times y to the 12. I could put it like a dot in between to show times. You don't really have to. So when you combine them and it's adding, you just multiply those. And this is my answer. It's now written as a single log, so I'm done. Now this one has three parts. This doesn't have a power. That doesn't have a power, but this one does. So I'm going to rewrite this once. Log base 6 of x plus log base 6 of y plus, and again, this one has a power. So I'm going to write log base 6 of z to the 6th power. Okay. Now, notice I have them added again, and to write them as a single one, all I would do when they're added is multiply those together. So I would write log base 6 of x times y times z to the 6th. And one thing I want to point out, it does not matter if this says log to the 6th. It could say just log. This could say natural log. It doesn't matter. This part doesn't matter. The rules are the same. So this one, this I can keep as is, but this I want to write as a power. So it's log of 3 minus, when I bring that 2 up, it would be log of 8 squared. Okay. Now, if I wanted to, I could square that 8 squared first, or what, yeah, maybe I will do that. So this is log of 3 minus log 8 squared is 64. Now, what we have there is subtraction. And when you have two logs subtracted and you want to write them as one, you divide the two. You take the first one divided by the second one. So we would write that as log of 3 over 64. Now, truly, if it's a plain number like that, you should reduce the number if you can, but I don't think I have any that you have to. Okay, but truly you should if you can. Like if it was a fraction like 2/8, you'd want to write it as 1/4. Okay. So this next one, again, I'm going to bring these up as powers. Okay, so this first is going to be natural log of x to the 20th minus natural log of y to the 4th. Now notice here, I had just a plain log. Here I have natural log. That doesn't matter. Okay, what I'm looking for is like, do I have a power that I need to bring up? And then is it added or subtracted? And if it's subtracted, remember what we do is we divide them. So what I would do back here is I would just write this as natural log of x to the 20th over y to the 4th. And those have two different variables, bless you, so you can't change it anyway. Okay. Now, when you have a half, first of all, in this one, I'd have to bring the 6 up. And this half is a power, okay? So when I write this, I'd write it as log base 9 of c to the 6th plus log base 9 of x to the 1/2 power. Unfortunately, we can't leave that as the 1/2 power. So today, if you ever get something to the 1/2 power, you're going to write it as the square root of x. And you could add this to that cheat sheet if you wanted, if you think you wouldn't remember it. If you get x to the 1/3 power, you'd write it as the cubed root of x. If you get x to the 1/4 power, you'd write it as the 4th root of x, and so on. Okay, so how I would write this then is log base 9 of c to the 6th plus log base 9 x to the 1/2 power is the square root of x. And you have to write it as the root, not the fraction. Now I'm adding, so how do I put them together if they're added? You multiply or divide? Multiply. So I would go log base 9 c to the 6th times the square root of x. And that would be your answer. We have one more page and then we'll be done. So this one again, I'm going to bring these powers up. Okay, so that first one I'm going to write as log base 5 of 2 to the 6th plus log base 5 of 4 to the 3rd. Now, because this is plus, I combine them as 2 to the 6th times 4 to the 3rd. When you have variables, like if that had said x to the 6th, y to the 3rd, you're done. You don't have to do anything. But when there are two numbers like that, you actually have to evaluate this. So you would just go to your calculator and you'd go 2 to the 6th power times 4 to the 3rd power. So if we did that, 2 up arrow 6, and then make sure you do your right arrow to come back down, times, and what was it? Two to the 6th times 4 to the 3rd. 4 to the 3rd, and then it's 4,096. So if you were on the test and you stopped here It's not like you'd lose all the points. If it was 2 points, I'd probably take off a half a point if you stopped here. But you do need to evaluate that just on your calculator, which is 4,096. Right? If I look at this next one, I have 4 to the 6th minus 11, log of 11 to the 3rd. So this is log of 4 to the 6th power minus log of 11 to the 3rd. Now, if you wanted to, you could evaluate these right now, or you could condense it down. And if it's subtracted, remember when it's subtracted and you add it into 1, you divide. So on top, you'd have 4 to the 6th. On the bottom, you have 11 to the 3rd. Now in this, you do still have to simplify, but if we just put this whole thing in our calculator, we'd get a decimal, and we don't want that. So what we would do instead is we would evaluate what 4 to the 6th is, put that on top. We'd evaluate what 11 to the 3rd is, put that on the bottom, and leave it as a fraction. So 4 to the 6th power is 4,096. That's going to go on top. And 11 to the 3rd power is 1,331. That's going to go on the bottom. So on top, we get 4,096. And on the bottom, we get 1,331. Okay. Now notice these all have a hat. What did we talk about would happen if you have all of those to a half? What is a half? It is a square root, right? So what you would do here, you would have log base 5 of, and I'm going to skip the step of writing as z to the 1/2. I'm going to just write as the square root of z plus log base 5 of the square root of x plus log base 5 of the square root of y. Okay. They all are added together. I want to condense them. When you condense adding, you multiply. And here's the deal. When they all have the same root, you can write one big square root and put z, x, and y under that same root. And I would never give you one that like one's a half and one's a third. I'd never do that. I'd always give you the same root. And that's how you'd write it. So this one here, again, the 1/3 would go here, the 1/3 would go there. So you don't really have to write this step, but I will for this one. So basically here I have y to the 1/3 power, and here I have z to the 1/3 power, okay? And some of these steps you can skip, but y to the 1/3, remember, is the cubed root of y. And z to the 1/3 is the cubed root of z. Now notice these are all added, which means we're going to multiply. So when I put them together, my x is just going to be normal by itself. But do you see how both of these are cubed roots? That means I can put both of them under the same cubed root. If you didn't, that's not a super huge deal. Like if you wrote it as cubed root of y times cubed root of z, not the end of the world. But if they're the same, you really are supposed to put them both under the same. One more. So this one, we have m to the 2nd, k to the 3rd, and y to the 8th. So again, like I said, some of these steps you can skip. You don't have to write all of these, but Now this one has a combination. It has these two added and this one subtracted. So I have to put it all as one. So I'm gonna write log base 4. What do you think I do with these two? If it's plus, I multiply. So on top I have m squared k to the third. And then if I'm subtracting this one, where do you think this is gonna go? On the bottom. Do you get that? So this is on the bottom like that. That's super hard. All right, so I'm gonna get you guys your worksheet. I still am finishing the key, but I will get that done and put it up on the podium. There was one thing I noticed on here, you guys. If you would go to number 16. The last, you know how there's 3 things added together? The last part of that should be 4 log base 8 of z, not x. So that very last x, if you change it to a z. I didn't make a key before I made the copies, so didn't notice that. That was on number 16.
I use this one.
The one in here, so you, yeah, you can grab that one.
Yeah,
I think
thank
I
you.
have one here. Somewhere I do.